So for number one, we were told that we were selected to simulate the checkout process in an e-commerce store, and they didn't give us many things. They gave us the interval times, which is the time between customers' arrival. So they gave us it's between 1 to 15 minutes, rounded to the nearest whole minute. They also gave us the service time, which is the time required to service each customer, and it's uniformly distributed between 1 to 8 minutes. So we were required to create a Microsoft Excel spreadsheet to stimulate the checkout process. The simulation should also calculate two measures of performance, which is the average customer time in the system and the proportion or the percentage of time the server is idle. And we were told to simulate for 20 customers and to simulate for 3 hours. So right here on the Excel sheet, we have the first column, which contains the customer ID. Since we're told to simulate for 20 customers, so the customer ID runs from 1 to 20, which is the number of customers we're told to simulate. Then we go to the inter-arrival time, whereby these numbers, they're already given. They told us to generate random numbers. We use the formula rand between, because you need to generate random numbers between 1 and 15 minutes, which is the occurrence between when a particular customer comes, rounded off to the nearest number. So between 1 and 15, these are randomly generated. Then we go to the arrival time. The first arrival time is the same as the inter-arrival time. And then the second one, you just add the arrival time with the next inter-arrival time to get 9. So after getting 9, just add 9 with the next inter-arrival time to get 12. And repeat the process for the arrival time. And you get for all the 20 customers. Now when you go to service time, they told us also to generate between 1 and 8 minutes. So it was in the question, it required the time required to service each customer is uniformly distributed between 1 and 8 minutes. So this was already given. So we used the formula run between 1 and 8 to generate random numbers between 1 and 8 minutes. So this is generated. So the service start time is it's basically, so for the service start time, the first one is 3, and to get the next one, you have to put marks in the formula to ensure that the previous customer is finished, that they start service for the next customer after the previous customer is finished. So that's how you get the service start time. And then for the service end time, you just get you get the service end time by adding the service time to the service start time. I think it's very clear. Service time to the service start time. 8 plus 3 is 11. 7 plus 11 is 18. 2 plus 18 is 20. That's the service start time. So the waiting time is the difference between the service start time and the arrival time. So when they start service, basically when they start serving the customer, when they start working on the customer. So 3 minus 3 at the time that the customer arrived is 0. That's the waiting time. Then we go to the next one, 11 start time minus 9, which is the arrival time, which is 2. Then we go to the next one, 20. So if we go to the next one, 18 minus 12, which is 6, which is here. So you do the next for the next. You can just drag down, obviously. And the time in the system, do the opposite. You do when the time ends minus the arrival. So you get 11 minus arrival, which is 8, which is the time in the system. You do the next one, 18 minus 9, which is 9. And you do the next one, 20 minus 12, which is 8, and so on and so forth. And then for the idle time, which is a bit tricky, you get the difference between the arrival time and the service end time of the previous customer. So if you want to get the arrival time, obviously the idle time for the first customer is 0. If you want to get for the next customer, they said you get the difference between the arrival time, which is 9, and the service time of the previous customer. the service end time of the previous customer, provided if the arrival time is greater. So if the arrival time for this guy is not greater than the service end time for the previous customer, which is 11, then the idle time will be 0. Then if we get for the next one, is arrival time bigger than the service end time? No, it's not bigger, so it's 0. And let me show another example. This one is 7. So we get the arrival time for this, which is 31, minus the service end time of the previous customer, which is 24. That's why you get 7. So this one is 3. How do you get it? So you go to this row, get the arrival time, which is 45, minus 35, minus the previous service time, the service end time of the previous customer, which is 32, which makes it 35 minus 32, which is 3. That's how you get the time. Yeah. So now, so doing all that, we have the average customer time in the system, whereby this one says self-explanatory. You just get the what? The formula is here. The time in the system for everyone, and then you get the average. It's pretty self-explanatory. And then you get total simulation time, which is 180. They told us to simulate for 3 hours. So there is 180 minutes in 3 hours. And then for the total idle time, which is the server idle time, I think it's the, you get 180 minus the sum of the server's time. So 180, which is the total simulation time, minus the sum of the service time. Yeah. And then you do for the proportion of the time the server is idle. This one is a bit tricky, whereby you get the sum, but for the formula, you see, let me show you. The sum of the idle time of the customer divided by the last end. As you can see in red, it's that 197 is the service end time for the last customer times 100, because we're looking for proportion, in percentage. So we get the total sum of the idle time for the customers over the service end time of the last customer times 100. Yeah, and that's how you do this.